Hey, in today's video of Open Source Explored, we're going to be going through this project by Neon. It's called YC Idea Matcher. The concepts we're going to cover in the video are about OpenAI embeddings. So YC Idea Matcher, the basic idea is you can read up here, submit your idea and get a list of similar ideas that YC has invested in before. And here's basically how it works. Drawer that sort of popped up. Let's see, yeah, and it pops up again. So let's say we want an HR app powered by AI. I think this might be too short. That helps me hire. So I do a search and it's basically making a call to the YC API. Well, it's going through our database basically, and it's already been filled with YC companies from the YC API, and it's finding all the companies that are related to our prompt that we've put in. So humanly.io, we empower companies to present their best selves. And Lena.ai, Lena AI build a virtual assistant that answers employees' HR. That's basically the entire app. Let's do, for example, another one, an app that helps me get to inbox 0 using AI. So let's see how this one performs. Compose AI, so this one is an AI writer, Akiflow, and so on. So you can see if email search for iPhone from 2010. So you can see if an idea you're working on already exists. So it's really simple app, small basic concept, but it's a really nice app to learn from how it works. So yeah, in terms of how it actually works, you can actually read this, and this explains it. But the first step is basically they went to YC, they used their API, and they stored all the companies in their database. So if we take a look here, this is a YC API. The first company is, I guess we have YC as its own company, then there's Monzo Bank and so on. And this data, basically Convoy, this data is then stored in our database. Next part we do is we create an embedding, which is basically a vector. What does it say? Next to each company description, we generated an embedding, which is a vector list of floating point numbers. For example, the word car can be represented using the following vector. We then use Neon with PG embedding, which makes it possible to store and retrieve vector embeddings in Postgres. And then when the user submits a query, we go and check the similarity. So the final query is basically going to be something like this, where we search our database for all companies. Whoa, where did that go? We search our database for all companies, order them by embedding array basically. So it compares our embedding of this new searched query we've put in to the array, and we limit it to 5. So we return the 5 that are the closest match. And the source code is available on GitHub. So what I just said probably isn't like fully understandable, but we're going to dive now into the code and like sort of fully understand how this works. It uses the OpenAI Embeddings API. So if we just take a look at the project, what that looks like. So the project is very small. You can see sort of a bunch of files. And it's a Next.js project, sort of we're used to Next.js, Tailwind, Postgres. Neon is basically a company that helps host like serverless Postgres. So they're the ones that put this project together. But it's what we're going to be mainly talking about is OpenAI embeddings. So you can see there's a script which is generate embeddings. That's one part. And if we go into the app itself, we see API route. There's just one API endpoint, 60 lines of code, and this basically goes and does that comparison that we saw of order by embedding and, well, how do I do this? Order by embedding, array embedding. But first we're going to sort of go through it step by step and sort of see the first step is generate embedding. So this is just a one-time script we basically run. What we do is we create a new database pool. This is basically, this new Postgres pool. And what we're going to do is we're going to create companies table. So we're going to write this query, which basically says if we don't have the embedding extension, then basically create it. And then the rest is create table if it doesn't exist. So here you can sort of see the table we're creating, ID, name, website of each company, and so on. And I guess the most important bit is the embedding. So all of this is basically just like, taken from the from the YC API, and we're just storing it in the database. We're not doing anything special here, as we're going to see below. But the embedding, this is sort of something we're doing extra with OpenAI, creating this embedding. Okay, so first we've gone and created the table. That's sort of the create companies table. Then here we're gonna scrape the companies. So to scrape the companies, you know what, let's sort of just jump down. We've got a few different functions here, but to run the script, basically, if we run the script, we're going to do create companies table. That just sort of creates the structure. Then we're going to scrape the companies and then, I guess, end what we've done. So for scrape companies, we're going to go to YC. Let's see the definition of this. We're basically using Axios to go to this URL. We get some JSON back, which is companies and next page. We go through all the companies. For each company, we basically generate an embedding based on its long description, and then we store the company in our database. And then if there are more tables, more pages, next page, we keep going through this again and again. So 2 bits we need to look at are generate embedding and store company. Store company, all it does is literally like takes the company we've created with the embedding and it stores it in the database. So that's pretty easy, and so on. Here we've got got the company data, and here we've got an array of numbers, and you just store it in the database. So what is the generate embedding, which is the more interesting part? So here we go to OpenAI, we call their API. We call embeddings, we use adder2. I think this is what's recommended these days to create your embeddings. And basically, for each company, we're taking the long description and we're sending it to OpenAI, and we get back an embedding, which is basically an array of numbers. As well, okay, I guess here it's any type. As you can see over here, it's an array of numbers. So that's all we're doing. That's how you create an embedding in OpenAI. Super simple. Call this endpoint, send it whatever you want, send it just like sort of a bunch of text. There's nothing really else you have to do. You select the model, and now we've created our embedding. And with this embedding, we can go and compare things to it in our database. So yeah, we've generated the embeddings, we've stored it. Now we basically have an embeddings with basically 2 bits of information in it. Our database has the company details and the embedding. And the embedding, we said, is an array of numbers. And that's all we need basically to run our next scripts. So if we take a look, the one API route we have in the project is API/idea/ route. So API/ID is /idea is what we're going to use. It's basically using runtime edge. This is the location. It's using upstash for rate limiting. So basically people can't call, I guess this means you can't call more than twice in a 5-second window, and so on. For the database, we're using Neon. So this is basically the Neon database serverless package, but you could do this really with any Postgres database that supports embeddings. Here we're sort of storing the ID or doing it anonymous and so on. This is all just about the rate limiting, but here we actually get to sort of what we want to do. So first what we do is we get the body from the request. We use Zod to validate that the message is in the correct format. So if you remember before, I tried to write a short message and it was less than 20 characters, so I got an error about it. So basically this API expects to get idea in the body, and it has to be in between 20 and 140 characters. So then we validate it. If it's been validated, well, if there's an error, sort of just return the error. And if, assuming it's all good, now we actually have a string over here, the idea, which Zod has validated for us. And what we do now is for this search query, we actually go and create another embedding. So we created an embedding for every single company, but also for the idea we type in, we're going to create the embedding. And this is basically just copy paste of what we had seen before. Not fully sure why they did it as a copy paste instead of creating one function. Maybe, actually I just don't know, probably should have been pretty easy, but either way, it's the same thing. Maybe it works a bit differently. They wanted to use fetch, I don't know, but instead of Axios. But basically it's just a copy paste of what we saw before. Here's the prompt, here's adder2, and so on, and it's a post request to OpenAI, basically embeddings endpoint with the OpenAI API key. So once we've done that and we've gotten the embedding, now we actually want to search our database for the items to which are closest in length. So we covered this when I started going through the repo, but this is sort of the main bit that we're looking at. So if we sort of just break this down, the select, so we've got sort of select the different fields that we want to get back. Okay, cool. Then we're getting it from the company's table, great. And then order by, this is sort of the main point, limit 5, so we only want 5. But how are we ordering the results? We're basically saying, I want everything back from the company's table, right? If we basically had this, but then here we're saying we want 5, but how are we ordering these 5? Which are the 5 that should be selected? And this is basically going to be order by embedding and array embedding. So this list of numbers, we're going to see which embedding, which array of numbers is closest to the numbers of our prompt, basically, that we put in. And how that works is it uses a distance function. What OpenAI recommends is cosine similarity. That's basically what the embedding extension in Postgres is going to be doing for us. I assume it's using cosine similarity, but it could be using something else. And in terms of what cosine similarity means, it basically means if you have a vector, so these are examples of vectors. Here you can see vector A and vector B, they're pretty similar. They have similar sort of angle going up to the right and so on. And they look quite similar. Whereas if you look at A and B here, they're not at all similar. And here, they're not only, these are sort of unrelated. These aren't unrelated. These are actually sort of very similar, but in the complete opposite direction. So these distances basically is how we're going to calculate what is closest to our response. Which embeddings are closest. So that's sort of what is happening behind the scenes. We get some number that says, okay, the distance between A and B is quite close. We should return A and B in our search. We shouldn't return A and B from this example over here because they're like sort of minus 20 in terms of similarity. They're really not similar. So that's basically what's happening here in the code. That's what's happening on that line, and that's what we return to the front end. So if you've understood all of that, you understand the project. Last thing we're going to do is just sort of look at how the front end goes and calls this endpoint in the back end. Here you can sort of see the root layout and the page. This is where the logic is happening. So if you go to the home page of the project, you will see this page. So here you can see YC idea match it over sold out slash. So this is just the home page, and this is the entire app basically. And you can see here we're using React Hook Form. We are, but also using React Query. So in terms of the homepage logic, 90 lines of code. Here we're using React Hook Form basically to set up a form. Here we're using React Query for the mutation, and all we're doing in this is calling our endpoint /API/idea that we spoke about before. That goes and does the search basically. Here you can see when the form's been submitted. So I guess when the form's been submitted, all we're doing is calling React Query, and that's sort of doing the rest of it. And once sort of we get the result, what happens once we get the result? I guess once we get the result, the result data goes in here, and then we display it to the user. So here you can see our form, handle the submit using React Hook Form. Here you can see we've got the same, we've got some validation here. One nice trick you can do, by the way, I know this is sort of just a demo project they put together, but you could use the same validations that Zod provides, and I think you would do, so you could share the validation we had on the back end, and I think you would do that something like this, Zod Resolver, and you could sort of put your Zod Resolver in here. So that's sort of like a nice trick to know about, a good way to share types and validation between the front end and the back end, so you don't need to do it twice yourself. And yeah, submit button. So if we just take a look at what that looks like ourselves, so we're going to refresh this page. Here you can see the form we just had, some text, a submit button, and when we hit the submit button, it's going and showing us all the results down here in a list. And here you can see data.data.map, and here you have all the different companies, and they're all being listed. And you can see here all this does is display information about the company. It shows some images. It has a bit of text and so on. It has a badge, and you can see that exactly here. You can see the badge, the tags, and so on. And this is just displaying what YC has on their backend. Yeah, so that's the entire project. I really like this project because it's so simple, but you can really learn a lot from it because it's it's a full example, but it's a simple example. You can basically understand everything about this project, in the last 5-10 minutes that we've gone through it. It's this page basically is calling our API idea endpoint. Here we do the rate limiting, we do the call basically, and yeah, that's it. In terms of the final parts of the project, so if you're here for embeddings, that's it. I'm not going to talk any more about embeddings. You know what, maybe I will. where it embedded, like just as we finish off about embeddings. Embeddings can be useful for these sort of, you can see this on the OpenAI website, by the way, but it's great for search. So the whole thing about embeddings is like when two pieces of like text are similar that we saw, so that search works great for that. So that's sort of what we did just now. Clustering, so where text strings are grouped by similarity. So we could say, okay, these 10 embeddings are very similar, these other 10 are very similar, and we could have like sort of different groups, and trying to find, okay, we have 5 different clusters within our database, and that could be helpful. Recommendations, like with items with related text strings, and so on. Anomaly detection, so it could be like 99% of strings are like very similar, and then sort of one is just sort of like hanging out, doing like sort of a bit random. So that's an anomaly that you might want to detect, and so on. You could have classification as well, where basically you could have maybe like a 100 tags or so, and then you know, let's say we're classifying emails, you send over 100 emails and you classify them based on those 10 tags, based on what's most similar, and so on. So yeah, I hope you enjoyed that on the embedding side. And the final part that I'll go through right now is some of the libraries that they use in terms of the front end, if that interests you. So here you can see sort of in the code components, a UI folder. When I see this, it basically means someone's using Shadcn. And so the person on this project, they didn't actually go and type this all up. They basically used this project, which is really nice and becoming really popular these days, but it has lots of pre-built components basically, and it works very well with Tailwind if you use that as well, which I'm seeing almost every project uses today. So here you can sort of see different components. Let's see some sort of more interesting ones: combo box, data table, data picker is like fairly complex, and so on. So if you need any of these items for your project, you can just like come here and do that. So yeah, there's 100 component libraries out there, and this is sort of another one that does things well. And what's cool about this one, Shadcn, is in order to add this to your project, so you'd use the Shadcn, well, I'm not sure what to call this, but you use the npx script basically, and then the way to use it is button and like components UI button. So basically running this script, add button, is going to add the button component to the input. So all of this code, like the primary button should look like this, secondary button should look like this, and so on, and all this logic around it. So this is what add button is going to do. It's just going to move something into a UI button component. And if I now ran the script and did like, maybe we can try and run it. Let's see, add popover. Let's see what happens here. Okay, I got to run in it and set it up. But basically, if that had been set up properly, then you'd see a popover component set up here. And what's nice about this is it's different to some other libraries where you have to go and sort of rely on what they do and then pass in props and change it. In this example, let's say you don't want the primary button text to be white. Let's say you want it to be red, for example. So you can do that like very easily. You can just sort of change the Tailwind yourself. So this approach is sort of similar to the Tailwind approach as a whole. Tailwind UI made it so you sort of copy in components, and it's not that you're installing an npm package. So it's the same idea here, and all your components basically show up in the UI folder, and then you can use them in other places as you would. I assume there's a button. The button is going to be the submit button, I guess. Let's sort of just find where this is. But yeah, we saw it before, but it's a submit button on the form here, and yeah, you can pass in extra props. You have his loading, you have the size, it's type submit, and so on. So that's Shadcn. It's built off of Radix UI, which you can also become familiar with, which is really nice. But yeah, here's sort of a profile component, so you can also sort of use things from here. You have a nice drop down, and so on. Let's see the hover card, nice component that I recently used as well. The very last thing in terms of the UI, if we refresh this page, okay, how it works. So this drawer is a call component, and it comes from a library called Vaul, which is quite new. And here you can see it's sort of like iOS, and look at that, like at the background, how it sort of fades in. Super cool, and you can drag it down, and obviously this works great on mobile as well. So I think we might sort of, I guess here it's not doing that whole animation in the back, but here you can see it is. But yeah, very nice. Open source on GitHub, obviously. And yeah, that's the end of the video. If you enjoyed it, we'd love for you to subscribe, share it with your friends, and we will be back next time.